Video to show you how to use technology on the two proportion test, like we did in class yesterday by hand. I'm going to show you all the technology today, and hopefully it makes some sense, and it's going to make it life so much easier. And let's do one. I'm going to show you one example. That should be enough. I'm going to show you how to do this on the calculator and on StatCrunch. So tomorrow when you come in, hopefully we're ready to go, and you can pick whichever one you want. It doesn't matter to me which one you go with. They both work really well. So here we go. It says, since the Hawkeye instant replay system for tennis was introduced in 2006, men have challenged 1,412 referee calls, with the result that 421 of the calls were overturned. Women challenged 759 referee calls, and 220 of the calls were overturned. Women don't challenge as much. We want to use a 0.05 significance level to test the claim that men and women have equal success in challenging calls. Part A says test the claim using a hypothesis test. Part B says test the claim by constructing an appropriate confidence interval. And then part C, based on the results, does it appear that men and women have equal success in challenging calls? Okay, let's go calculator first. Show you it because I think it's really pretty cool how that one works. So let's split the screen here so you can see both. And there we go. I already have some stuff up there. So get out there and go to stat test. And last week we used number 5, one proportion z-test. Look at number 6, 2 proportion z-test, which is exactly what we're doing today. Just hit the number 6 and it pops up just like this. I've already entered the numbers for us to make it a little quicker. If you look down here where it says P1, notice the claim was that men and women have equal success. So I'm going to go with that one and being not equal because it doesn't say that the women are greater, men are greater, anything like that. It just said challenge, but the claim is that they're equal. So the opposite would be not equal. So go down to calculate, hit enter, and voila, all of a sudden your Z score pops up, which is a big deal to see how it matches up with your critical value, and your p value shows up. And p value is big there, it's 0.685. Since it's bigger than 0.05 in the problem, obviously we would reject HO, and because we're rejecting it, we say there is not sufficient evidence to support the claim that men and women have equal success, because that was the claim. Okay, so we would reject that claim, and that's a prob test. Now, and one more thing you can do in the calculator, if you go to stat and test, because part B says do a confidence interval. When you scroll down, I think it's letter B. When it keeps scrolling down here, yes, letter B. Look what B says. A 2 proportion Z interval, which is a confidence interval. So I'm going to hit enter. And again, I've already typed in the stuff. The confidence level is 0.95 because the problem gave me 0.05. So I'm going to go down there to where it says calculate, hit enter, and look at the top. Oh my goodness, there's your confidence interval. Did all that work for you. Now, one issue with this problem is 0 is included in that confidence interval, which means there's, I'm 95% sure, confident that 0 is in there, or that the real p value lies in between those two numbers. So that means the difference could be 0. I mean, we talked about sometimes the confidence interval gives you a little bit different answer than the p-value method or the critical value method. And this is the case where it did. So using that, we could not reject the claim because 0 is in there, which means they would have the difference is 0. The difference in the two calls is 0. That's what the interval gives you, is what's the difference in the challenges, which in this case is nothing. So let me show you StatCrunch, and then we'll be done. Let's see here, make that go away maybe. All right. Sorry about this. Be patient with me just a second. There's that back. Oh, so great at this. Let's go to StatCrunch. Okay. Split the screen for me. All right. When you go StatCrunch, we're going stat, proportion stats, 2 samples today, because obviously we're doing 2 different samples. Go with summary. And we're going to type in the successes. Okay, for the men, it was 421 successes out of 1412. For the women, it was 220 successes out of 759. All right. If we're doing a hypothesis test, we always want that to equal 0 because we want our hypothesis, remember, is always P1 equals P2. And if that's true, then P1 minus P2 is always 0. The difference is 0. There's no difference in the two proportions. Now, this is not equal to, which is exactly what I want. I'm just going to hit compute here, and there it is. It's the exact same p-value we saw a second ago and the exact same z-stat we saw a second ago. All right, so works just as well. Now, how about confidence interval? Well, with a confidence interval, go to the same place, go to proportion stats, 2 sample, with summary, except this time, well, it's happened the same thing. I thought I was hoping to say the numbers 421, 1412, 220, and 759. And this time, let's click off. We'll click on the confidence interval, and that automatically clicks off the hypothesis test, and that gives me that P1 minus P2, which is what we want. So for 95% certain or 95% confidence, I'm gonna hit compute, and it gives me my lower limit and my upper limit right here at the end, the last two numbers, which were exactly what I wanted. That's their error right there, which we worked with yesterday. We saw the formula yesterday to how to find the error. There it is. I just snapped my fingers if you can tell. Also gives you the counts over here. There's the whole deal. And then you can make your answer part C based on either one of those. So, wow, technology is awesome. Makes life so much easier. And we'll work on that in class tomorrow like we always do. And if I can get rid of this, I will see you tomorrow when you come in.